All right, so how do we predict the shape of a molecule? We use a model called Vsepr, and it's actually pretty simple. So Vsepr, again, allows us to predict the shape of central atoms. So a big molecule will be made out of multiple shapes, but we can tell the shape of each central atom. Vsepr stands for valence, shell, electron, pair, repulsion. And if you read that, it tells you pretty much exactly what Vsepr is, right? And Vsepr says that electrons, either in lone pairs or bonds, repel one another. That makes sense, right? They're both negatively charged. And so they want to get as far away as possible. So for example, if we have a molecule of carbon dioxide, the bonds, the carbon-oxygen bonds, are repelling one another, right? There's enough repulsion here. And so they want to organize themselves so that they're as far away as possible, but still connected to that central carbon. And so if you think about the way to get these two pieces as far away as possible, it would look something like this, right? They can't get any further than that while still being connected. And that's actually the correct shape of CO2. And so by just thinking about getting these electron groups as far away as possible, we can determine the shape of any central atom. Not only do bonds repel one another, but lone pairs as well. So for example, if we have a molecule of SO2, SO2 has two bonds and then two lone pairs. So there's all kinds of repulsions going on here. And if you think about getting these three pieces of the puzzle as far away as possible, you would end up with some shape, something like this. Right, so to determine the shape of the molecule, or at least part of a molecule, we have to consider two things. Number one is the number of electron dense areas. So these are our lone pairs or bonds. And then another thing we have to consider is how many of these are lone pairs versus bonds. And then we just use a handy dandy chart, which you'll memorize, of course. And it's really not too bad. So here you can see on the left, we have the number of electron dense areas, right? So these are bonds or lone pairs. And then you go over and you say, okay, how many of these electron dense areas are lone pairs, right? So let's go four areas of electron density. And then one of them is a lone pair. Then we just go down into this chart and the shape is trigonal pyramidal, right? So we'll review these shapes in these next series of videos.